Welcome. Is it too loud? So today we are going to talk about test-driven development. What exactly is test-driven development? The first three stages of test-driven development is write a failing test, make the test pass, refactor the code, and go around that cycle all over again. The main point is not to write a production code without writing tests first. What are the three laws of test-driven development? You are not allowed to write any production code unless it is to make a failing unit test pass. You are not allowed to write any more of a unit test that then is sufficient to fail. You are not allowed to write any more production code than is sufficient to pass the one failing unit test. If you refactor these three sentences, they will look like this. Write production code only to make a failing unit test pass. Write only enough of a unit test to fail, and write only enough production code to make the failing unit test pass. One other important thing when writing unit tests is the AAA testing. AAA is not acronym for Alcoholic Anonymous, but it's for arrange, act, and assert. Arrange is the part where you mock something, where you initialize new objects. The act itself is self-explanatory when you want to save something, update, perform a certain operations, and assert is when you validate something. So that was the presentation, and now we will go with some practical examples. One of the reasons why I chose this exactly is because so many people have found examples of test-driven development with calculator. So we are going to change the calculator example, and we are going to implement something with beer. In order to implement something with beer, here I have a unit test project and a shared library. For this testing, I'm using XUnit with n substitute for mocking. So let's see how can we start with some examples. First, we have to write a unit test for, let's say, beer basket. So let's actually create a class like that. And actually, I'm using another library here for performing asserts. It's called shouldly. So let's make the first unit test. We want in our beer basket to accept any type of beer, which will show the total of anything. So we need to have something like beer shopping cart, which is new beer shopping cart. And we want items here. So let's say I'm going to use n substitute here, and this is how we mock certain things. So we are expecting a list of items. So this class doesn't exist. Let's create. So now we can see that we have a clause that says beer shopping cart, and it expects something in the interface, and we have an unknown class. So let's fix the interface first. Okay, now we have an interface, but we don't have beer item. Now we have a beer item. Let's see what's happening here. Let me see where, yeah, this is internal, should be public. Okay. Now we have this, it's compiling. So what is our expected result? We are expecting any type of total. Again, using and substitute, we are expecting any type of double. So how are we asserting that? Beer shopping cart, let's name this subtotal, should be expected result. Now, we don't have this property. Let's generate it. Let's make it double. Now let's run our unit test. So now it works. So what will happen if we add an actual item here? Or that we want the result to be double, for example. Let's just copy this one. I'm going to accept any beer with 0 total. Let's change the expected result. Let's run the test. Let's run all of them. Now it works. So let's add an actual item. Let's change the interface here and say something like this is new list, and let's add new, and we want to have one beer with a price of 100. Now, because this doesn't exist, the test will fail. So we need to generate something in the beer item constructor. Let's make this quantity, and let's make this one price. Okay. Let's run our unit test. It will run, but we are expecting this to be 100. So if you see here, it says that subtotal should be 100, but it was 0. So we need to refactor our shopping cart. How are we going to refactor that one? Let's say something simple like if we have beer items, let's say, we have at least one. Let's just return the price of the first one, otherwise it's 0. So price needs to be public. Okay, let's see our test now. We have 3 passing tests. If I run them again. Okay, now let's extend this and add another logic for 2 beers. What we want to do here is add a new item, and let's say we want another one with a different price of 150. This is simple mathematics. This should be 250. So as the assert says, it should be 250, but it was 100. That means we have to refactor the shopping cart on how it handles the subtotal. So let's change this. I'm just going to comment on this code. And let's say beer item dot aggregate 0 is the default, and we want double as total, and we have beer item here, and we will calculate the sum with a simple lambda that this one is total, so the total is beer price. Okay, let's run our unit test again. We have a passing test. So if we want to go a little bit more crazy, let's create another test that has different quantity. Have total for one beer with quantity. So let's say we want to buy 3 beer. The expected result should be 300. So this should be 300, but it was 100. That means that we have to refactor our shopping cart again. And in our logic for calculation, we are only adding the price to the total without the quantity. So how can we add the quantity? Let's expose this as a public property. And let's do something like this. Beer quantity multiplied by beer price. So if you know simple mathematics, we don't need an extra parenthesis here. So now everything is working. So how can we do something to parameterize the input? In next unit, there is something called theory, and let's write one. Okay, let's reuse our code from before. And instead hard coding values here, let's pass the quantity, let's pass the price, and we should expect a total of quantity multiplied by price. So how can we make this work with input parameters? There is something called Inline Data, and let's say we will add 2 beers with a price of 100. Then let's add another one with 120. Let's add another one with 150. And if you feel lucky, let's add this one. Will it work? So we have 4 different input types and one test. If you can see here, here is the variation of everything. So let's randomize everything. How can we randomize? Let's say I want a random quantity, but just to provide the price. That means we must find a way to generate this item here. Let's say between 1 and 8. So let's add the quantity here, and let's add the price here. And now we have randomized data that works with the randomizer and some defined input price. We can even randomize this if you want. Let's run all of them. Okay. So now when you have somewhat production ready code, you can refactor. For example, we don't actually have to know, the shopping cart doesn't actually have to know what's the subtotal. We can create a separate function for that that can calculate the subtotal for each B writer. So if we want to achieve that, we can do something like subtotal, and let's just return the price multiplied by quantity. So that means we have a public exposed method from the B writer, and let's just tweak this a little bit. Let's run our unit test again. So in short, time for questions. Yeah.
So this is a pretty basic example of TDD. I usually have CRUD services, but how do we go about creating more complex business rules? For example, let's say you have a campaign. That means that you also have to have a client and many other things. So is it a good idea to use a database instead of creating random data with facts and theories?
Yeah. First of all, this was a very basic example of what is TDD, because people usually start with implementation and then write tests. If you want to use the full-blown solution, what we are actually doing in our project is using dependency injection to inject repositories. We are using in-memory database to simulate foreign keys and so on. So if you set that up, you must have some base class, for example, that will do the setup, proper injection. Use in-memory database. You can use SQLite, or even you can use a local SQL server or some other type of database if you want to perform tests. For example, in a behavior-driven development, we have tendency to use real databases that are only for testing. You can expose that database and you can adjust your tests instead of generating something random to use actual data. Does that answer the question?
It does.
Not sure this is easier or not. A bit of follow-on from that. Imagine you're testing data context. Let's say entity framework. If you're testing a system against any memory database, would you also still create separate tests for the data context? It saves, verifies the data, and then use something different to test your service layer.
Very good question. Depends on the actual load of the application. What you might want to do is create a specific test to ensure that your database is up and running and have some structure. If you have loads of data, that's why we use frameworks like nsubstitute or mock or Rhino, just to mock data that we are sure that exists there. But if you don't have a very large data set, you can use an actual database or something from in-memory.
Okay, so I guess it's a bit of a follow-on from that again. So entity framework, it's well-defined third-party library. What's the point to stop testing? What's the point that you don't test? For example, you don't need to test that the entity framework can connect to SQL server. It probably does, but do you test your saves? Do you test your structure?
Entity framework is the layer that reads and writes data to a database. I'm writing tests to ensure that my service actually passes through the correct data through entity framework and then ensuring that it's written there. So basically we are not testing entity framework, but we are testing the mechanism that the data traveled from one service to some lower layers. It was saved to a database, and then we are asserting if the saved data is correct.
Final part, I promise. Can we have an example of that on the GitHub that follows the tech talk, please?
Right now, or would you like to see something?
It doesn't have to be right now. Whenever you get the chance to add it on to Git, would be very useful.
Okay, I will publish this code right after the presentation ends on Git, and maybe next part or some other session, we will do in-depth entity framework testing.
Awesome. Thank you.
Okay, now let's say you are testing a business rule that includes an outside API that you also have to pay for each time you call. So how often do you test?
Mock API server, just so you won't run off all of your credits. So if you want to communicate with API, there is a very cool library called Floral, and it has a NuGet package that's specifically for unit testing. So it can mock any request to any API. You just have to define what's the input and what's the correct output from that paid API service. And we actually use that in a lot of scenarios.
It's usually not important the amount of credits that you waste, but it's that unit tests always have to return the same results. If you implement a third-party services in a unit test, then you can't always guarantee the same results. For example, you test creating a campaign in some third-party service. You create the campaign, and the first time you run the test, it will work. But the second time you run the test, the campaign already exists there, and their server says, yeah, this already exists, and it will return an error. So your test is now failing because it expected the same result, but it's different because of the data that already exists. As Vlatko said, this is the reason why you always mock third-party services. You define what you want to send and what to expect back. So you're testing if your services work, not if their services work. You're assuming that their services always work, and it will always be the same result. You test how your system reacts to that.
Mocking will save your life. It wasn't a mock or a pun. Other questions? In that case, let's wrap this up. This is the link where you can find the example of today's presentation. If you have some ideas like how are we going to test entity framework, you can send me an email, write me on Teams or whatever. And right now I'm going to test my production code that I just wrote. So thank you for your time.